Hey everyone, welcome back to 197 Concepts. So in this video, I'm going to discuss with you a program of DOSBox, a program of DOSBox where we are going to find the length of a given string. Okay, so you might be familiar with the string. So string is nothing but just a collection of characters, and I have also discussed with you how you are going to display a given string in onto the uh, display of the DOS box. Okay, so in this video, I'm going to discuss with you how to find the length of the given string. Okay, so without any delay, let's dive into the video. And as you can see, I have already the code that I'm already having the code right here in front of me. Okay, so here I just missed the line. That is nothing but assume. Okay, we will keep it this way. So I believe it's going to get an error because I have missed the line assumes yes colon code. So let us see that later in the video. Okay, right. So now, as you can see, I have initialized the data segment. Okay, and let me change the pen. So I have initialized the data segment. So I have initialized the data segment, and the string that I am going to find the length is hello world. Yeah, be careful. You need this dollar symbol, and the string has to be within the quotation marks. Whatever you type here, that's not our problem. That's not the computer's problem. You have to end it with a dollar, and it must be within these quotation marks. Okay, then what I'm going to do is I'm just defining a variable with the name of length, and I'm going to initially give a value of 0. So this length variable, or this length, yeah, you can say this length variable is used to find the length of this complete string. It will be going to calculate all the characters present in this. I don't believe it's going to count the space. Let us see that. Okay, so if we remove the space, how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So dollar will not be calculated. Okay, so yeah, 5 plus 5, that's 10. So length at the end of the program should be 10 if we don't calculate this space. Okay, we will see that when we are going to execute the program. Otherwise, we will get the character 11 or the number 11. Okay, finally, we are ending the data and we are going for code segment, and then we are starting the code segment. Hope you have understood up to here. Now, next. So, from here onwards, it's going to be a little bit confusing. Just stay with us. Okay. So, first of all, I have to erase all the things that I have here. Okay. Now, let's go back to this pen and yeah. So, right. So now what I am doing is I'm starting the program, and I need to move the data that I have, means my string, that is hello world. Okay, this has to be stored in data segment. Okay, now I cannot directly pass this into data segment. I have to go through AX register, then to the data segment. So initially it is going to be stored somewhere in the data. Okay, somewhere in the memory with the label of data, and this data can directly move into the data segment. Okay, though it is data, you cannot directly move it, so the rules won't accept this. That's why I have to go through AX. That's what I'm doing in these two lines. So I'm moving the data into accumulator register, then I'm moving from accumulator register to data segment. Okay, now I'm using LEA, so that is load effective address. So this is going to load the very first uh, string address. So if I have the word hello itself, okay, so this will be stored as say 10, then this will be stored at 11. 20, and this is stored as 40, and then this is stored at say 23. Okay, so I don't I'm not sure. So this is not my problem where the characters is going to be stored. So computer will do this automatically. What When you get LEA, immediately what the process is going to do is it is going to pick this number 10 and it is going to keep it in the source index. Okay, source index, and from there on it is going to be incrementing itself. So for this better understanding, you have HELLO. So this is 10, 11, 12, 13, 14. Okay. Whenever LE is executed, I'm going to the number 10. So 10th location of the memory, and this is going to be stored. This character, not this value, this character, yeah, since we are not using this bracket, so this value is going to be stored in source index. Okay, it is going to be stored in source index. After that, one by one. So source index plus 1, which will give you 11, then plus 2, which will give you 12, and so on up to 14. These will be stored in source index, right? Okay. Now, the next point, what I'm going to do is I'm simply just clearing. So I'm simply just clearing the CL register. So I'm just clearing out the CL register in order to make a count. Okay. Hope you have understood up to here. And the main part is going to start from the next character. For that, I have to erase this all first. Right. Now, starting from here, starting from here, the very first thing that I am doing is I'm moving the AL, I'm loading AL with square brackets of SI. So from this line, from load effective line, what we have in SI is, like I have told you before, if H is stored, the first character is stored as 10th location of the memory. Now this 10th location will be stored in SI. Now AL has to load the character H. It doesn't need it doesn't need the number 10. Okay, so what I am going to do is I have the number 10 in my source index, right? I have the number 10 in my source index. Now, when I give this square brackets, what I am telling the system is the number 10 is a memory location. I don't want this number 10. Okay, source index, of course, it is having the value 10 in it, but I don't want this value to be loaded into the AL register. Instead, you go at the 10th location of the memory and fetch this character H. Then load this character into the AL. That's what I'm telling. Okay, so that's the meaning of these square brackets. So wherever you get a square bracket, for example, if I use BX also like this, then that means I don't want the value that is directly stored in the BX. You go to the value that is present at the BX and then fetch that data, load it into the other register, whatever you have. If you have a DX or CX or AX, whatever you have. Okay, so what these does is these makes the value that is present in the within the, so like DX here in the case, if you have a value in DX and you are placing square brackets, what this square brackets does is the value that is present in this register will be the address. Now initially it was a value, right? Initially it was a value, now that will become an address. So that is what I'm doing. Okay, and then next, in the next line, what I'm doing is comparing it with a special character. So since I have used dollar symbol to end the character, to end the string, now what I'm going to do is I'm from the hello world, hello world, I'm going to fetch this character, load it in AX or where AL, and I'm going to compare this with dollar symbol. Okay, so since both are not equal, definitely I'm not going to execute this one. So this is JE, that is jump if equal. So move to this label when both my dollar symbol and my character that is loaded in the AL are same. So since this condition is not satisfied, what I'm going to do is I'm not executing this line, I'm executing this line. So increment CL. So initially CL was 0, 0. Now it will be incremented to, CL was initially 0, 0. Now CL will be 0, 1. That means I have counted this character 1. And now what I'm going to do is increment SI. SI plus 1. That means initially SI was at 0 or it was at 10. Now what I'm going to do, I'm going to add it with 1. That means the pointer is shifting to position number 11. Right. Now, next, jump next character. That means you're coming back to this line. You're coming back to this line. Again, this whole cycle is going to be completed or executed. That means now before we have H loaded into the AL, now E will be loaded into the AL and it will be compared with dollar symbol. So since this is also not equal to E is also not equal to dollar symbol, again the cycle will be repeated and L will be loaded and so on up to D. After D is compared with the dollar symbol, finally this dollar symbol will be loaded into the AL and it will be compared with this dollar symbol. Since both are equal, the JE condition, equal condition satisfied, and then you have to jump. So in that case, these three lines will not be executed. So these three lines will be skipped and the program will directly make a jump from there to here. Okay, from there to this label. What we are doing, of course, after every count, after every comparison, we are updating CL. So let us say the final value I got in the CL is something like 9 or 12 or whatever value I have. This value is going to be stored in the variable length that I have defined in the data segment initially. Now, simply I'm just going to end the program with these three commands. Okay, that's a logic behind the whole program. I hope you have understood it. Let us try to execute this. Okay, so first of all I have to open DOSBox, then going for the full screen, and now mount cc colon backslash c. Okay, cd to 8086. That's it. Now MASM, not MASM, I need to edit. Okay, now I'm pasting the program. Yes, I have pasted the program. So now I'm going to save it with strcmp.asm. Okay, so file exit. Now, first of all, clear the screen. MASM strcmp.asm. It has three severe warnings because code segment is not reachable. It's saying code segment is not reachable because we have missed the line here. What is that? Assume cs colon code comma ds colon data. Now if you save this and now MASM strcmp.asm, you won't get any errors. Right now linking it, link strcmp.obj. Right now AF Debug strcmp.exe. So this will open our debugging screen, and now if you execute it, AX1831 loaded, then DS is load DS. So data segment. If you observe the right side of the screen, bottom side of the screen, and bottom right of the screen, bottom right corner, you will now get your hello world character. Okay, so those addresses where the first character, the second character, third characters are stored from the hello world is represented by the numbers 48, 45, 4C, 4C, 4F, all those in the data segment. Okay. Now I'm going to load the effective address and source index. Observe source index, since it is the first address, so it's just going to be 0 and CX. So initially it's 2B. Now I'm going to clear that off because I don't want to mess up with my character count, right? Because I need to find the length of the string. That's why I'm just going to clear it out. Now I'm going to move the first address of the source index into the accumulator register. So 1848. Observe that 1848. Now compare 1848 with 24. So where is 24? So if you observe in the data segment, the last B after 9A at the bottom of the screen after 9A. No, I'm not able to use the mouse here. Yeah, Epic Pen toolbar. No, yeah, I believe I can use now. If you observe here, the 24 is stored here. So this is nothing but, so this is H, this is H, this is E, this is L, this is L, this is O, W, O, R, L, D. Yeah, it has stored the space also. So not this one, W, O, R, L, T, and this is the dollar symbol. Okay, so this is the complete storage. Now I'm going to compare this 48 with 24. Since they're not equal, then I'm shifting to E, and 45 and 24 will be compared. So both are not equal. Then I will jump to L. Then I will go for this. Finally, after spacing, space will be compared, and finally after comparing D, I will come back to D, dollar. So dollar will be compared with itself, and since both are same, it's going to stop the program execution, right? Now let us see. So yeah, F1. So increment JZ. So jump F0 flag. Okay. So JZ, again increment C1, count is done, and increment SI to 1. Now I'm going at 45. So AX will be loaded with 45. C 1845. Now again I'm going to compare it all. Okay, so what's the number? 4C. So 4C, you won't be able to understand here anything. Just observe AX source index. Okay, in the AX it should be 1824. Then we will be executing the loop. So 20, 57, 4F, 52, 4C, 44. Now when we execute this, now 24, right? Now compare AL comma 24. Yes, it satisfies. That's why the zero flag is 1. So when comparing, when you're comparing two characters or two strings, yeah, two characters or two bits, the if both the bits or both the characters are staying same, the output you get is 0. Okay, so basically it's going to do the AND function between AL and 24. Since both are same, not AND, you can say it as XOR, both, because both are same, you get the output as 0. All the result will be 0. Every result will be 0. And since the complete result is 0, the 0 flag will be activated. That's why you get the 0 flag as logic 1. And since the complete value is 0, the complete result is 0, it's not going to jump towards the previous character. So simply it's going to move CL, that means 0 0 0 0 B, somewhere to the address of 0 0 0 C. Okay, now where to get that? It's not updated here. Okay, again, since it is a string operation, what you have to do is, this is just a logical debugging. What you have to do is, you have to come here and you have to execute the file strcmp.exe here. No, yeah, that's because I have not written another code. Just a minute. So I hope I will keep it in this way, because closing it will be much easier. First CLR, now MOUNT amount C colon backslash C CD8086, and edit. what is that? strcmp dot exe, not exe, dot asm. Here I'm going to do a little bit changes. So finally what I'm going to do, move length comma ax. Now what I'm going to do is move ax comma 09h and int 21h. Okay, right. So I'm going to save this and exit from here, and simply what I'm going to do is MASM, yeah, I have to repeat these steps. MASM strcmp dot asm colon, then no errors, link strcmp dot obj, and now instead of going for the debugging screen, what I'm going to do is I'm going to execute the file directly, strcmp dot exe. No, so it's not able to display the string value. Yeah, I have to again come for the DOSBox. So DOSBox, and now mount c colon backslash c c. Now cd to 8086 and edit strcmp dot asm. Here I need to display this length. Okay, so for that, or else simply I can move this into dx, right? So that I can get the length the itself like this. I'm going to keep it like this. Save. Now exit, and again MASM strcmp dot asm. Okay, what's that error? Warning, operand types must match. Yeah, I know what I did. So I have used here dx. Yeah, I will move this to cx, right? Now save, exit, MASM strcmp asm, and link strcmp dot obj, and AF Debug strcmp dot exe. Now if you execute this, so yeah, I'm observing that it has to come up to 24. So 4f 52 4c 24. Okay, it has jumped quickly. We need to do it much slower. Okay, now so f11, yeah, 4c 4f 20 57 4f 52 4c 44 44, now 24, comparing it. So it's going to skip that, and dx 0b. Okay, so 0b is nothing but the value 10 in the hexadecimal value. So if you are representing the value 10 in hexadecimal, that's going to be your 10 count. So if you count hello world, HELLO, that's 5, and world is WORLD, That's 5. 5 plus 5, 10. 10 plus, I believe it has counted the dollar also. So yeah, up to 9. 10 is A and B is 11. No, it has skipped the dollar. It has counted the space. So based on that, it tells that your length of the string is 11. Okay. So hope you have understood this program. That's it for this video. See you in the next video. Thank you.